Hello everyone, today let's take a look at Quantipus number 87, another conditional probability question. In this question, we are given that there's a 40% chance of rain on Saturday and a 30% chance of rain on Sunday. However, it is twice as likely to rain on Sunday if it rains on Saturday. So what is the probability that it rains at least one day this weekend? Okay, so first let's just try to understand this problem. We have two events. Let's call Sat the event that it rains on Saturday and Sun the event that it rains on Sunday. So if we draw out the Venn diagram, obviously there's some probability of overlap in the event that it rains on both days right here. There's some probability that it rains on Saturday, but not on Sunday. And then there's some probability that it rains on Sunday, but not on Saturday. And there's also the probability that it doesn't rain at all on either day, which is out here. And it tells us that there's a 30% chance of rain on Sunday. So we know that this Sunday circle has 30% probability mass and 40% chance of rain on Saturday. So this Saturday circle has 40% probability mass. And it's asking us, what is the probability that it rains at least one day this weekend, right? So it's asking us for the total probability of an event being within this green bubble here, right? The union of these two events. So just one more time to write it out more formally, we know the probability of rain on Saturday is 40%, the probability of rain on Sunday is 30%, and we're asked the probability that it rains on either day, so the union of these sets. That's what we're trying to find. And the only thing prohibiting us from solving this is that we don't know the overlap, right? We don't know the probability that it rains on both days, so we can't effectively calculate this yet. But we know by the inclusion-exclusion that we've done a million times that the probability of a union of two sets is just equal to the first set plus the second set, and then we've overcounted this middle region twice, so we have to subtract it off one time. So this is going to be the formula. And again, the only thing missing is this intersection, but we have one more piece of information that will help us solve it, and it's basically that it's twice as likely to rain on Sunday if it rains on Saturday. So what exactly does this mean? Well, basically it's saying the probability that it rains on Sunday, given that it's rained on Saturday, is equal to twice the probability that it rained on Sunday, given that it did not rain on Saturday, right? Which we denote as Saturday complement. So what's the probability that it rained on Sunday given that it's rained on Saturday? Well, now we know with 100% accuracy that it has rained on Saturday. So now the land of our total probability gets reduced just down to this green Saturday bubble. And now that we're within this bubble, what's the probability that it rained on Sunday? Well, obviously it's just going to be equal to this red part, which we can call x divided by the total probability mass of the green circle, which is 0.4. So this is just going to be equal to x on 0.4. And just note that x is the exact thing which we're trying to solve for. It's the probability of the intersection between Saturday and Sunday, right? Now let's look at this term. What is the probability that it rained on Sunday given that it did not rain on Saturday? So we're given that it did not rain on Saturday, so that means our outcome space is now restricted to everything outside of the Saturday bubble, right? Everything that is not within this bubble. So within this bubble, we had 0.4 probability mass. So that means that everything outside of the bubble must have 0.6 probability mass, obviously. So our denominator for this is going to be 0.6. And what's going to be in the numerator? Well, it's just the probability of something satisfying our condition that it rains on Sunday, given that now we're within this new space, right? So it's going to be everything within here that's not within the Saturday bubble, right? So let's just call this blue space here y, and that's going to be our numerator. If you wanted to write y more formally, you could also say that it's equal to the probability of the intersection between Sunday and Saturday complement, but it's easier to visualize this way, so we're just going to call it y. And now what value did we want to solve our original equation? Well, we wanted the probability of the intersection, which was x, so let's solve for x here. So let's just write out our equation again. We know that x divided by 0.4 is equal to 2 times y divided by 0.6. So we're trying to solve for x here, but we have two unknowns and the other one is y. So what is y in terms of x? Well, if you notice up here, y plus x is just equal to 0.3 because collectively they make up the Sunday bubble, right? So if we note that x plus y equals 0.3, then it's pretty clear that y is just equal to 0.3 minus x, and we can plug it back in here and solve this pretty easily, right? Now we're going to have x on 0.4 equals 2 times 0.3 minus x on 0.6. So this is just basic algebra. We move the 0.6 to the other side, so we have 3 halves x equals 6/10 minus 2x. Then we move x to the other side. We have 7 halves x equals 6/10, but that's just 3/5. And then we multiply each side by 2/7, we get x equals 6 on 35, and that's in lowest terms. And now we know x, which was just the intersection between the Saturday and Sunday bubbles. So now we can just plug it in here. That was the only missing piece of our equation, right? We know that Saturday plus Sunday is going to give us 7/10. So we need to subtract off 6 on 35 now. So multiply the left one by 35. We get 245 on 350 minus 60 on 350. And that's going to give us an answer of 185 on 350. And we reduce it to lowest terms, we get 37 on 70, which is the final answer. So again, these problems, we can visualize it with the Venn diagram, make these formulas a lot easier to understand, right?